All right. Do you guys see that okay? That looks good. Okay, we are talking about the last part of our titration assessment. There's lots of kind of like odds and ends to it, so I'll kind of like do things in different sections. If you guys remember, when you started this titration assessment and you were thinking about part A, or sorry, I shouldn't even say part A, it was basically the internal assessment resource. So this was kind of the introduction to what we were doing and why. The main thing I wanted us to think about was this component here, which is the reasoning why we are doing all of this titration stuff. So what you're trying to do is quantify a substance. We're trying to think of how much is there. So if you guys remember with ion identification, the first thing we asked is what is it? And then the next important question is how much is there? Because that's going to influence then the effects of different items. So we are thinking about how much is in household objects. So we've done sour cream and we've done buttermilk as our two. And then for the assessment, you guys were looking at vinegar. And we're looking for the acidic components for all three of those items and trying to quantify how acidic it is. So some background information for the teaching version. So everything on the yellow piece of paper, this whole investigation was trying to investigate sour cream. And we were trying to calculate and quantify the amount of lactic acid in that sour cream. It is normally around 0.55%. However, for practical purposes, so that way it's a little bit easy for us to get a reaction, we've decided to purify it and to concentrate it down a bit. And so in theory, what we should have is 11% of the solution being lactic acid. And what we are doing with this task is basically trying to confirm whether or not that is the case. Part D is doing that final evaluation. We have collected all our data, and let's see, does it actually match what my technician and my lab and my manufacturer is claiming, is what we're trying to answer. Are we okay so far with that? Okay. So looking back over here, what you'll notice is that there's another set of calculations that we have to do. I'm going to hold off on this for the time being because I want to kind of think of this in chronological order. So I want to think about the stuff that's on the summary of the report. There are potentially 3 things that you need to write about in your report. The first bit is a justification of your procedure. And if you guys notice, I have marked it as optional. And that's really important that you guys kind of pay attention to that because you don't necessarily need to write this justification. You only need to write this justification if in part A you did not get your excellence. So this first one here is basically your second chance of getting excellence for part A. And I did post your unmoderated grades onto Google Classroom. I'm also happy to have a chat with you to let you know what you got in that section and whether or not you need to basically do this first bullet point. Cool. A lot of you guys opted out, so a good number of you guys are gonna have to do it if you want to get an excellence. Are we okay with that so far? All right. The second bullet point here is a reflection on your accuracy improving techniques. If you guys remember, in your part C, I gave you a little space to basically kind of jot down some of the things you were doing so you could remember it for when you go to part D. That was basically the idea behind it. Yeah. If you guys also remember, this I gave you guys as a printout of a list of notes. If you guys remember the titration technique, I gave you step by step what you need to do and the explanation to why. And so that's basically how you're going to answer the second bullet point. So it'd be stuff like, I made sure to remove the funnel so that way I didn't have drops of liquid fall in after I measured the burette, which would have changed my volume. And if that changed my volume, then it would affect all my calculations later. And I would inaccurately calculate the, in this case, lactic acid. Are you okay with that so far? The last one here is an evaluation of the results. So basically what you are talking about is, do the results match what the manufacturer and the lab technician is claiming when they say that the ethanoic, oh, that should be lactic acid, sorry. The lactic acid is at 11%. Are we okay so far with all of those ideas? Sort of? Okay. Let me give you a crash course then in what this first part is, so that way you guys are aware of it. It's basically what you should have written in part A. Let me remind you about what you were doing in part A. So in part A, if you guys remember, let me grab stuff here. You guys did a rough neutralization reaction. You had those little ball pipettes, little squeezy ones. And you basically put 1 ml of the acid in there, and then you're putting 1 ml at a time of the base, and you want to get a rough ratio of what the undiluted acid would neutralize with your base. You then found that that was not going to work because you were going to use buckets and buckets of sodium hydroxide, and so you're like, I need to dilute this guy down, so that way my ratio is far nicer. You then did these calculations here, looked at several different options on how you were going to dilute it and how much of the diluted solution you were going to use, and it gave you a rough estimate of what your titrate volume was going to be. Are we okay with all that? Ring a terrible, terrible bell. Okay. The next thing was that you filled in your proposed procedure. So you basically explained, how am I going to do the dilution and what would I expect for my titrate and what would I expect for that color change. And then the last thing you guys did was you justified your choice. So with justifying your choice, there were lots of different things that you could talk about. The first thing I talked about was explaining why you needed to do that dilution. The second thing was talking about things like upper and lower limit. So why did we want our titrate volume to be between 10 and 25 milliliters? The last thing you could talk about is the trials and how many trials you could get out of your stock sample that you made, which you guys obviously have done the titration, so you know the importance of having one set of the diluted solution. Remember, each time we make a new diluted solution, there's going to be slight variations, and so ideally I should only make the dilution once. So basically, how many trials could you do? So that was the explanation that I was looking for part A, and if you were missing that explanation, you didn't get an excellence on part A. The good news is, for part D, you can still have a chance to write that explanation for you. So if you didn't get an excellence, I would highly suggest you write this bullet point and you get it checked off by me. The main thing you can now do, because you have more information, is that you can compare it with part C. So you can see the proposed procedure that I gave you versus the one that you created. So I'm just trying to see, did I print that on? Yes, I did. So in this case, and I don't know if it was very clear on that. Maybe I have it here. I have it on the front of part D. So in part C, what we did was we did 25 milliliters of my undiluted stock, and I put it into a 250 ml flask, and then I filled it with water. What full dilution is that? 25 into 250. Tenfold. So my dilution factor here is tenfold. Maybe, the other thing that I'll ask is, what size sample did we take from there last week? We look at part C. Part C says we used a 10 ml pipette. So I did a tenfold dilution. And I did 10 mils of that sample. That is what I did in my procedure. Is that the only correct answer? No. When you guys did this working, you would have found out that there were quite a few that worked. So if you are trying to do a second attempt at part A, what you can start doing in your explanation then is compare your selected method versus my selected method. And again, talking about upper and lower limits, talking about whether or not they both work. What I happen to have done is the one that I selected was a 10-fold dilution and a 10 mil aliquot. So in fact, the method that I had created was the exact same one that I gave you. So you might have done the same. You might have chosen a different one. You might have decided I want to do a 25-fold dilution and take a 25 mil sample. And that is also a correct way to do it, because in this case, you're increasing some of your accuracy because your volumes are a little bit larger. So it's more or less the same thing. There's more than one way to get the right answer, is what I'm trying to express. So if you are doing a second attempt at this first one, just keep that in mind. That's what I'm kind of looking for. All right. The second one was about accuracy improving techniques. I'm not going to go through that one in depth because I've already talked about it when we did the titration lesson. But I will pull up the marking schedule so you guys are aware of how I'm marking that accuracy improving techniques. So if we're looking at this for part D, if you're able to describe an accuracy improving techniques, that would be enough for achieved. So saying, I have taken off the funnel. I made sure there was no air bubbles. I need at least 2, and I can tick you off for an achieved. Are we okay with that so far? A nice backup option is for part C, when you're doing the titrations, if you jot those things down, I can still refer to that as your kind of safety net for achieved. For the merit, I need an explanation on why it would improve your accuracy. So removing the funnel, so that way I make sure I don't get any extra drips. Looking for no air bubbles to make sure that there's no like loss in volume of my solution, that sort of thing. And again, this is on that sheet that I was talking about for last week. For the excellence, I want to see a real thorough justification on how is this an accuracy improving technique? How would it impact your data? All right. So thinking about like, if I had overestimated my volume of acid, then my calculations would result in a downstream effect that I would overestimate the concentration of the acid because now I have more moles of acid in the solution than I was initially intending. Cool. Are we okay with that? Do you want me to write any of that down? Or do you think it's more or less straightforward? That's what I thought. All right, last thing is the evaluation of the results. So, is it actually on here? Yes, it is for the excellence. Okay. So the good news is that these calculations that we're doing here is only required for the excellence. If you're not aiming towards excellence, you don't have to worry about doing this. What I'm trying to do is undo all of my work to figure out the original concentration. So I go to part C, and I am looking for the concentration that I found that when I did the titration. And with my data, I found that it was 0.138 moles per liter. Like that. Based off of the reading of what the instructions I gave you, we know it's a 10-fold dilution. And so we want to backtrack and go, what was the concentration of the undiluted solution? So should I multiply or divide? Multiply. Because it's 10-fold diluted. The original concentration is 10 times more concentrated. So that's why I'm multiplying. So I would do the 0.138 times 10. Where's my phone? Get my calculator for you guys. I know it's just moving the decimal place, but it's good to still see it. Clear. So 0.138 times 10. So I have 1.38. So that's the original concentration. We okay with that so far? Okay. The thing to keep in mind, though, is that this concentration was given to us in grams per liter. So that's what I'm trying to check it against. Yeah. So if we look at our first information, let's see where you are at. All right. So in theory, if it's 11% as in the solution, then when I convert it back from moles to grams, I should have 110 grams per liter when it comes to the lactic acid. So if we remember our conversions, we are trying to go from moles back to mass. So I need to rearrange this equation. Mass is going to equal the moles times the molecular mass. If I want to convert it back. So what I'm going to do is I'm going to take this number up here, 1.38 moles per liter, and I'm going to multiply it by the molecular mass of the lactic acid, which is 90.08 grams per mole. What I'm going to see is that my moles and moles will cancel out, and I will be left over with grams per liter, which is what I want. So let's do that. Times 90.03. So I get that my lactic acid concentration is actually 124.31. I'm going to do 3 significant figures and units. So 124 grams per liter is my final answer. Cool. Keep going. All right. Last thing then that we talk about is the evaluation of the results. So I got 124, and I noticed that the answer is 110. So is that the same number? No, it is higher than what the manufacturer is claiming. So what I need to then justify is why would the manufacturer's claim be higher, or sorry, why would my results be higher than what the manufacturer is claiming? It could also be that when you guys do these calculations, it will be lower, and we need to explain why is it lower. So some things we can think about. If my results are higher, we are trying to predict why the manufacturer is claiming 110, but I get 124. One of the reasons could be is that they are making the product at a higher concentration because they expect it to degrade by the time it gets to the supermarket or by the time it gets onto the shelf. So it could be a brand new product straight off the assembly line, and it's going to be a little bit more concentrated than what actually the consumer will use because they're planning for it to degrade with time. So that could be one reason why your results are higher. Manufacturer has budgeted in for the chemical to degrade. So by the time it reaches the shelves, it will be at the correct concentration. Very normal thing that they do. On the flip side, if your results are lower than what the manufacturer is claiming, so I'm just going to do this in like parentheses just so you guys like know this, like if. Basically what you could be saying is that this is an old stock sample and so it has degraded. Questions, concerns, comments so far with this? And then there's one more reasoning that this could have happened. Or actually, I should say two more reasonings. The first could be because this one is not directly taken from the pure sample and we had to purify it with the technician. If you guys remember, that was one of the things that we had on our sheet. So I'll just find it. Here we go. So typically ranged at 55%. However, we purified it for it and we increased the concentration to somewhere around 11%. And that was the technician's work, the lab partner's work. So maybe the lab made a mistake in the purification process. I should just say purification process. The other thing is that the manufacturer could have a fail in their quality control. And I can tell you guys, when I worked in a lab, and it was an industry-based lab, quality control checks were really, really important before we sent anything out because we had to ensure that things were working. We often call them QC tests, quality control. So if you guys get into the scientific fields, this is something that you have to do as a manufacturer, and that's why there's a lot of science jobs in that sort of sense. So like you could work for Fonterra and you could be measuring like the sugar levels in their milk, for example. Especially important with like baby formulas and stuff like that. So I think we had an issue back in China where there was some sort of contamination with one of the Fonterra milks. Cool. Questions, concerns, comments? All right, that's it. So